Now here in this case, calculate current in 8 ohm resistance for the network shown below using the Norton theorem. This is 8 ohm. Here is the A point and this is the B point. It is the simple, and I am expecting the answers from your side. Remove the load resistance and short circuit the output terminals is the first point. I will write the same. Removing load resistance and shorting output terminals we get. We will remove the load resistance and we will short the output. How will be the figure? It will be something like this. It will be something like this. This is B point, this is A point, this is B point, and we are shorting these output terminals. This is 2 ohm. Its polarity of this voltage is already given in the figure, and this is Vx. This is plus minus, this is 2 Vx. This is dependent source. And this is 6 ohm, and its value of the voltage is 5 volt with plus and minus. लेकिन जब भी ऐसे प्रॉब्लम्स को सॉल्व करते हैं जिसमें वोल्टेज दिया होता है, when we are solving the problems based on whenever voltage is given and polarity is given, be careful about such problems while assuming the direction of the current. ये पॉजिटिव टू नेगेटिव ऐसे दिया है इसलिए इसमें करंट ऐसे है, तो इस लूप का करंट एज्यूम करते समय ये डायरेक्शन हमारा ऐसे ही होना चाहिए. If these polarities may be given opposite, ऐसे दिया होता, if these polarities are given something like this, in that case the value of the Vx is something like this, plus and minus here. In that case we have to take its current anti-clockwise. Otherwise the calculation will be wrong, because these are the polarities for certain current. That's why while assuming the current we have to follow these polarities. That is the case, or that thing we have to keep in mind for such problems. So here in this case, this is voltage Vx whenever load is present, and whenever it is short circuit, it is replaced by the short circuit. In that case, I will give some different name, Vx1. This is Vx1. Is it right? Now here in this case, I will give some name to this current. Maybe it is I1, and this current maybe it is I2. Is it right? But in what value we are interested? We are interested in this current, which is In. अगर हमें I1 I2 मिल जाएगा तो ये करंट क्या होगा? I1 minus I2, I2 minus I1. Its modulus value will be, the answer will be the same, because I1 minus I2 इसका difference तो same आएगा. Sometimes it may be positive or negative, but we are interested in the modulus value. That will be the same. So here we cannot use the nodal analysis method here, क्योंकि यहाँ पे zero resistance path है और हमें यहाँ पे करंट निकालना. And whenever we are interested in the calculation of the current in zero resistance path, we should not use nodal analysis method, because it will create the complex calculations. Now if we are applying the KVL to the loop 1, I will write the same. Applying KVL to loop 1. Applying KVL to loop 1. If we are applying the KVL to the loop 1, how is the equation? If we are traveling from this point in the clockwise direction, ये भी polarities पहले मैं mark कर लेता हूँ. Now here in this case, if we are traveling in the clockwise direction, negative to positive, it is a plus. How much is the voltage? Plus 5. Then positive to negative, it is a minus. It is minus. You can express in terms of Vx, or you can express in terms of this value. तो अभी Vx के बारे में नहीं सोचता हूँ मैं. I will write that is 2 into I1. This it is 2 into I1. You can write in terms of Vx1 also, because Vx1 unknown आने वाला ही है. Both are correct ways, but here I am using this. So here in this case, if we are moving further, then there is no element which is equal to 0. From this equation, this phi is equal to 2 into I1 is, in this case, I1 is equal to phi divided by 2, which is 2.5 amperes is the I1. Is it right? If we know the I1, then we will apply the KVL to the loop 2. I will write here, applying KVL to loop 2. If we will apply the KVL to the loop 2 and prepare its equation, if we are preparing the equation positive to negative, that is a minus 6 into its current, which is I2, is the potential. Is it right? Then we are coming down positive to negative, that is a minus 2 into Vx, which is equal to 0. After that, there is no element in the circuit. Is it right? This is the equation number 1. I will check, and I will take this as equation number 2. But to calculate its current I2, we should know the Vx. We must first find out the Vx. But Vx is equal to, what is the Vx? This voltage. How is this voltage? Its resistance into its current. Is it right? How much is the value of Vx? Means always calculating the potential, we have to travel from the lower potential to higher potential. Voltage निकालते समय हमेशा lower potential से higher potential की तरफ जाना है. Means negative to positive, that is a plus. How much is the voltage across this? 2 into its current. 2 into I1. This is 2 into I1, which is equal to 2 into I1, and I1 is the 2.5, which is 5 volts is the value of Vx. Is it right? If we know the Vx, then we can simplify this equation. Means this is, I will name it as equation number 3. Now we will substitute equation number 3 in equation number 2. In that case, how will be the substitution? This is minus 6I2 minus 2 into Vx, and Vx is the 5, which is equal to 0. Here in this case, how is the I2? That is minus 6I2, which is equal to, I guess, 10. Is it right? And this I2 is equal to 10 divided by 6, which is minus. This is minus. How much is the value? 10 divided by 6.
1.6.
Sorry?
1.6.
Your voice is breaking. Who is this?
1.66.
1.66. 36. You say yeah?
6.
6 sir, 6.
1.66 amperes. 1.66 amperes is the I2. Now we are not interested in either I1 or I2. We are interested in the IN. Therefore, this IN is equal to Norton's current. I will find out its value downward direction. I will find out its value in downward direction. That is A to B. If it is downward, which current is downward? I1. Its value is I1 minus I2. Because this is downward, this is upward. That's why it is I1 minus I2. Which is equal to, how much is I1? 2.5 minus, how much is I2? Minus 1.66. Is it right? Which is equal to 2.5 plus, this minus and minus plus, it is 1.66. How much is the value? This is 2.5 plus 1.6. How much is the final value?
4.16.
4.16 amperes is the IN, which is the Norton's current. Is right? If we know the Norton's current, then we are interested in the calculation of the Rn. And for the calculation of Rn, how is the formula? VOC upon IOC. Means we have to keep its terminal open, and then we have to find out its value. I will use the similar procedure. I will use the similar procedure here. I will start from this. For calculation of Rn, we will use this formula Rn is equal to VOC upon ISC, which is same as VTH upon IN. Now we will find out the VTH first, or VOC. For calculation of VOC, we will remove load resistance and redraw the same circuit. We will remove the load resistance and we will redraw the same circuit. How will be the circuit for this case? Just we are removing this branch, nothing else. It will be something like this. This is plus, this is minus. This is 2Vx. This is 6 ohm. Here is the A point. This is the B point, and we are keeping this point open and we are interested in this voltage. Travel from B to A using this path or maybe this path, your value will be the same. This is right. Here in this case, this first resistance is the 2 ohm. This is 2 ohm. This is 2 ohm. This is right. And here, this is plus and minus, this potential is the Vx. And this value of the voltage is 5 volt. It is 5 volt. This will be the circuit for the calculation of that. And we will have only single loop. That's why the current in this loop will be the different. This is Vx when load is present. When it is short circuited, we have named it as Vx1. In this case, that current will be the different, so voltage will be the different value. So we'll name this value as a Vx2. Then this will be the Vx2. And with these polarities, plus and minus, its current will be something like this here. What is the current? I will name this current as some other name, which is Ix. Mark the polarities. This is plus minus. Already its polarities are existing and its polarities are there. Apply the KVL to this loop. Now applying KVL to above loop, we get. We will apply the KVL to this loop, and if we are applying the KVL to this loop, how will be the equation? We are starting from this point. We are starting in clockwise direction. We are starting in clockwise direction. If we are moving clockwise, negative to positive plus, its voltage is 5. Then positive to negative is minus. Its voltage is 2 into Ix. Then positive to negative is a minus. 6 into its current, which is Ix. Then positive to negative is a minus 2 into Vx2, which is equal to 0, because after that there is no element in the circuit. Is it right? How will be the equation? This is 2Ix and this is 6Ix, means 8Ix. It's minus 8Ix. This is minus 8Ix. Is it right? This is minus 8Ix minus 2Vx, which is equal to minus 5, or 8Ix plus 2Vx, which is equal to 5, and this is the equation number 3. We have the two unknowns. And how many equations we have? Only one. For this figure, we have only one equation. Now, anyhow, we have to prepare another equation to find out the values of the unknowns. I mean, it is my interest. We are interested in the Ix or Vx. If we will get this part, this voltage plus this voltage, अगर Vx मिलता है तो ये voltage plus ये voltage, हमें answer पता चल जाएगा. Otherwise, we can use Ix. In that case, this potential is known to into its current will be this potential, means we are able to calculate this value. Otherwise, we can use another part. Here, we have to find out Vx in terms of Ix. It's directly We know what we know. Vx. How much is the Vx? Negative to positive, that is a plus. 2 into its current, and how much is this current? That is Ix. Yes, in this case, how will be the equation? Equation will be, I am writing the equation in terms of Ix and Vx and constant. This is Ix, is plus 2Ix. I am shifting this Vx to the next side. This minus Vx, which is equal to 0, and this is the equation number 2. We have the 2 equations and the 2 unknowns. Is it right? This is one equation, this is another. Because यहाँ पे हमने KVL अप्लाई किए in terms of Ix निकाल, लेकिन Vx में equation नहीं था. That's why we have calculated the value of the Vx, and we got the another equation. Now with these equations, find out the first unknown, which is Ix, and second unknown, which is Vx. Use anyone. Use the calculator and find out these unknowns, Ix and Vx. Yes. Anyone? Yes. इसके बाद आंसर है माधुरी. Saurabh.
Ix is equal to 0.41.
This is 0.41 amperes. 41 amperes. Vx
0.83.
is 0.83 volt is the value of Vx. Is it right? If we know the Ix and Vs, then we will find out the VOC, which is same as the VTH, which is equal to, we are traveling from, modulus value, we are traveling from the V towards A. You can use this path also, but I am using this path, negative to positive plus, its voltage is 5. Its voltage is 5. Then, positive to negative, it is a minus 2 into its current. How much is this current? Which is 0.41, which is equal to, find out the VTH or VOC. Yes. How much is the VOC?
4.18.
4.18 volt is the VOC. If we know the ISC and VOC, then we can find out this Rn. This Rn is equal to VOC upon ISC, or this is VTH divided by IN, which is not bus current, which is equal. Sorry. This is 4.18 divided by its current. How much is the current which we have calculated in the last case? Which is, I guess, it is 4.16. 4.16 IN. IN is this value. This is IN is 4.16 amperes. Is it right? This is 4.16. Find out its Rn. How much?
0.004.
004 ohm, or 1 ohm is the value of the Rn. Now we know the IN and Rn, then we can replace this complicated network by the Norton's equivalent network. How is the case? This will be the final figure. And reconnect the load resistance which is removed in the step number 1. This is RL. This is 1 ohm. And this current is how much? 4.16. This is 4.16 amperes. 4.16 amperes is this value. How much is the load resistance RL? We are interested in the calculation of current in this branch, 8 ohm resistance. 8 ohm resistance. In this case, the load resistance is 8 ohm. This load is 8 ohm. Therefore, IL is equal to 4.16 4.16. That is IN into RN divided by 1 plus 8, which is equal to, find out its load current. Find out its load current.
Point 46.
0.46 amperes is the IL. Is it right?